Okay, we're going to do some more on the Algebra 2 semester review. So we'll look at number 7 here. We have to match each polynomial with its end behavior as x gets larger and larger in the positive and negative directions. So, as x goes, when we have these rational functions where we have a polynomial divided by a polynomial, as x gets large, it tends to go to a certain number in these rational functions. It's called a horizontal asymptote for some of these. As a matter of fact, or maybe not always a horizontal asymptote. We'll look and see what we get, okay? In this one, when the degree of the denominator, that's the bottom number, the degree of the polynomial, remember this is highest exponent of the x is a degree, that's an x to the first power, so the degree is 1. There's no x up here, so the degree is 0. When the degree in the denominator is less than the degree of the numerator, the graph approaches y equals 0. And so this one is number 5, because the degree on top is 0 and the degree on bottom is 1. When the degree on the denominator is equal to the degree of the numerator, and the end behavior is y equals the leading coefficient. That's the number out front of the highest exponent, or x with the highest exponent. The leading coefficient of the top, a numerator, over the leading coefficient of the denominator. The degree up top is 1. The degree of the denominator is 1. Degrees are the same. Therefore, you have y equals, the leading coefficient of the numerator is 2, and there's an understood 1 in front of the x. So the leading coefficient of the denominator is 1, so you have y equals 2. So here, that's going to be the number 1, as that's matched with. Degrees are equal here also, because that's a 1, and that's a 1. So degrees are equal, so it's still going to be y equals 2 over 1, which is just 2. So this one's going to also be 1. That's kind of interesting, because we're not going to use the 2, it doesn't look like. Now, when the degree on top is greater, so the degree of the numerator is greater than the degree of the denominator, we divide the numerator by the denominator to find what y equals. We just divided 1 in the last video, so we can do this again. So here the degree is 2, here the degree is 1, degree is greater than the top and then the bottom, so we're going to do x minus 1 goes into 2x squared plus x plus 3. And remember we said, what we multiply by x times to get 2x squared, that will be 2x. Then we multiply that on the outside and get 2x squared minus 2x and subtract. 2x squareds cancel out. We got x minus negative 2x makes x plus 2x, or 2x plus 3. Ask ourselves, what do we multiply by x to get 2x? That's going to be a plus 2. So 2, that should be 3x, I'm sorry. That should be 3x. X plus 2x makes 3x, so we multiply it by 3. That's much better. Now we multiply that and we get 3x minus 3, whoops, sorry. We subtract that, and we end up with 3 minus 3 because 3x's cancel out, so we get 6. 6 is our remainder. When we're doing this and we're looking for end behavior, all we worry about is this. This is the end behavior. So in this one, y goes to 2x plus 3, so the graph approaches y equals 2x plus 3, so this one's going to be the number 3. And in the last one, we're going to have to divide also because the degree is 3 and the degree on the bottom is 1. So we're going to do x minus 1 goes into x cubed. So we ask ourselves what times x makes x cubed, and of course that's x squared. We multiply and get x cubed minus x squared, and we have to subtract. There's nothing to subtract from unless we put a 0x squared up here, so we're going to do that. Then we say that's going to be x cubes cancel, 0x squared minus negative x squared makes x squared. So we ask ourselves what times x makes x squared. It's going to be plus x. Multiply the x on the outside, and we get x squared minus x, and we have to subtract that. Again, nothing to subtract it from, so we do a 0x and bring it down. And x squareds cancel, and we get 0x minus x makes positive x. Then we do x. What times x makes x? That's going to be 1. We multiply that times x minus 1, we get x minus 1, and we subtract that. Again, there's nothing here, so we do 0, and we bring down the 0, and we do x minus x is gone, 0 minus negative 1 makes 1, and that means that x cubed divided by x minus 1 equals this plus 1 over x minus 1, but this is my end behavior, where it's going to, and so this is going to be number 4. And that's a long video for that 5 problem, so we're going to stop that with just number 7.